This is how to do your homework. I'm going to provide you a walkthrough so you can make sure to clear up any confusion that you guys might have for performing t-tests in SPSS. Now, here is homework number 8 on my computer, and you'll see here there is data, okay? There's pre-test and post-test memory performance for participants that receive sugar, and you have different scores here. Now, the first thing that you need to do for this homework is to answer questions which are directly underneath it. So what kind of t-test is appropriate in this situation? This would be a paired sample t-test. Now, it is a paired sample t-test because you have the same participants before and the same participants after. So it's a pre and post design. Now, the second question asks for pre and post sugar is what kind of variable? Pre and post sugar is not quantified and is the independent variable for this data. Therefore, in order for us to use this t-test, it needs to be a nominal variable, okay? Also called a categorical variable. Now, the number of words recalled is what kind of variable? This variable is going to be ratio. It's going to be ratio because participants could technically recall 0 words. So this is going to be a ratio variable. Now, the importance of this is when you are looking at data, you need to have independent variables that are nominal and categorical and dependent variables that are interval or ratio in order for you to be able to perform t-tests. Now, I'm going to skip over what could the null hypothesis be and what could be the alternative hypothesis. I am assuming you have enough background doing hypothesis testing now. And what I'm going to show you now is how to enter the data into SPSS. So I've put it in a Word document so you can kind of highlight all of it and push Control C, which takes a picture of all of this data, the whole picture. And now I've already loaded SPSS. I'm going to bring SPS over and put my highlight the cell in the upper left hand corner and paste the data. Now I've pasted the data, and so what I'm going to do now is I'm going to go down here to variable view. Here we have variable view, and I'm going to name the variables appropriately. So this is going to be participant number, okay? This is going to be pre-test. This is going to be post-test. And this is going to be different scores. Okay, now I've named all of these variables, and now I can go into data view. And you can see that their names have been followed, and each column has a particular name. Now you'll also notice, and I want to draw your attention, that each row in this situation represents an individual participant. So this is participant 1, their memory score on pre-test, their memory score on post-test, and this is their difference score. Now, we are now going to hit Analyze, okay? And there's a lot of options right here, but what you want to go down to is the compare means words right down here, because ultimately a t-test is comparing means and telling you whether those means differences are due to chance or whether they're due to a manipulation. So hopefully these names are starting to make sense. Now, because we want to run a paired sample t-test, we're going to go and click on paired samples t-test. Click on it, which then brings up this icon. And what I want to do is take pre-test, enter it into variable 1, enter post-test, and enter it in variable 2. You can kind of see this is the pre, this is the post. And that is all you need to do in order to perform a paired sample t-test as far as setup is concerned. Now you just need to push OK, and an output is going to appear on your screen. You can see right here, here's the title. You ran a paired sample statistic. These are the means for your pre-test and your post-test, number of participants, the standard deviations for each sample, the standard error of the mean for each sample. They even ran a correlation between the two for you. Now, here is the t-test. Okay, it's a negative 8.320 with degrees of freedom 19. Now, this is so large, okay, that we can actually reject the null hypothesis with a significance value less than 0.000, which is a really good sign as far as believing that we are actually finding an effect, and these effects are probably not due to chance. So you can make the conclusion that these results, okay, are probably not due to chance, that the sugar did improve memory performance, at least for this experiment. Now, I'm now going to go back to your homework. Okay, I'm going to move down to move data to SPSS, and that all I've done is I did all of these steps for you. Now, the output is provided below. Okay, so hopefully everything makes sense. You can kind of see the 8.320. Okay, all of the things I highlighted. Now the question then asks, based off the data above, what is the probability the differences are due to chance? Now I'm not looking for a particular number. If you wanted a particular number, you could go here. What I want you to be able to say is the differences are probably not due to chance, because we rejected the null hypothesis. That is ultimately what you're saying. When you say that you reject the null hypothesis, you're saying that your results are probably not due to chance. Okay? So what is your ultimate conclusion? You can reject the null hypothesis. Okay, you can reject the null hypothesis and ultimately conclude that sugar, okay, appears to improve memory performance. Okay, now if we were to do this experiment 100 times, this is the next question, 95 times the true value for the difference score would lie in the 95% confidence interval. What is the 95% confidence interval for this experiment? Okay, now for this experiment, I'm just simply for this question, I want you to look and notice right here. Okay, do you see this title right up here on the paired sample t-test? What this is telling you is that if we ran this experiment over and over and over, we would be 95% confident that the mean differences would lie between 1.83367 and 3.0663. We're 95% confident that is where our mean differences range would be 95% of the time if we ran the experiment 100 times. So an easy way to answer this question is just to go 1.83367 to 3.0663. And now you have answered the question for the first problem. Now let's go down to example 2. Okay? Now example 2, I told you in class, is an independent sample t-test, which means that you have different participants in the statistics class and different participants in the no statistics class. And we are looking to see if statistics improved performance. So you can see here you have the statistics columns and you have the no stats columns. Now what kind of t-test is appropriate in this situation? An independent sample t-test is appropriate in this situation because you have different participants in your two samples. Statistics enrollment is in what kind of variable? It would be a nominal, okay, also called a categorical. Okay, IQ is what kind of variable? Okay, IQ is actually an interval, okay, because it doesn't have a true zero, but the difference between the values is equal across all values. Okay, we're going to skip the null and alternative hypothesis. You can do that on your own. And now what I'm going to do is I'm going to take you through how to calculate, okay, an independent sample t-test in SPSS.